Hello, ladies and gentlemen. We're going to keep rolling with radians. So, first thing, we're going to identify terminal points. But I want to just make sure that we review all of the different radian values before I even do that. So, let's just make sure we did what we did the other day. Let's label all the different reference angles. So, remember, in radians, this is 0, or going all the way around is 2 pi radians. So, if 2 pi is 1 full rotation, then pi is half of a rotation. And if you want to take that in half, then that'd be pi over 2. And then you can realize that pi over 2 is 90 degrees. So 90, 180, 270, you need 3 90 degrees or 3 pi over 2s. So now we have our quadrant angles. Now let's do our 30-degree reference angles. As a reminder, if pi is 180 degrees, pi radians is 180 degrees, then if I do pi over 6, that will be 30 degrees. So I'm going to label this guy as a 30-degree reference angle, and then that is pi over 6. So the way I do this is I'll say, if this is 1 pi over 6, let's go all the way over here and say this is 6 pi over 6, right? That's pi. So if this is 6 pi over 6's, then one less than that is 5 pi over 6, and one more than that is 7 pi over 6. So this is your sort of reference. This is 6. So 1 less is 5, 1 more is 7. If you go all the way around, that'd be 12 pi over 6 because 12 over 6 is 2 whole. So 12 over 6 is a 1 full rotation. That means 1 less than that is 11 pi over 6. So those are your 30-degree reference angles. Let's do the 45-degree reference angles. So the 45s go right down the middle. And if you know that pi is 180, then 1/4 of that is 45, pi over 4. So you can count by pi over 4s. This is 1 pi over 4, 45 degrees. This is 2 pi over 4, that's 90 degrees, but 2 over 4 is 1/2. And then this is 3 pi over 4. So this would be 4 over 4 because 4 over 4 is 1 whole, and that makes this 5 over 4. You could call this 6 over 4. 6 pi over 4 reduces to 3 pi over 2. And then this is 7 pi over 4, which, again, this is 8 pi over 4. If you go all the way around, that'd be 8 pi over 4s. What else do we still need? 60 degrees. Okay, so 60-degree reference angles are going to look something like this. So I'll label this as being 45, and this will be 60. Okay. So if pi is 180, then pi over 3 is 60. 180 divided by 3 is 60. So this is 1 pi over 3. That'd be 60 degrees. This is 2 pi over 3. This is 3 pi over 3, but again, that reduces. 4 pi over 3 and 5 pi over 3. You want to keep going? 6 pi over 3. The only reason that the 60 degrees is kind of weird is because 30, if you count by 30s, you'll hit the y-axis. If you count by 45s, you'll hit the y-axis. But if you count by 60s, you actually skip the y-axis because 60 times 2 is 120. So sometimes that messes with people. Just realize that when you're counting, you have 1, 2, 3. You're breaking up the top of this into 3 chunks. 1, 2, 3. So it looks a little different, but it's the same game. Now that we've kind of reviewed that, let's go back and identify some terminal points. So I think I have a little cheat. There we go. Let's do this just to help me out. Okay, 2, 3, 4. Boom. Boom. Sweet. Okay. So I'll draw these and we'll identify the terminal points. So 3 pi over 4. First thing, if you see that it's something over 4, you should be thinking, oh, this is a 45-degree reference angle. So 45 degrees, 3 pi over 4, 1, 2, 3. That's in the second quadrant. If it's a 45-degree reference angle, if this is 45 degrees, then these have to be radical 2 over 2 and radical 2 over 2. And since we're in the second quadrant, x is negative. So this is negative radical 2 over 2, comma, radical 2 over 2. It's a 45, 45, 90. Across from 45 is still radical 2 over 2. Negative 7 pi over 6s. So negative means I'm going to go clockwise. So the 0, this would be negative 6 pi over 6s. So if I counted by pi over 6s, this would be negative 6 because we go clockwise. So negative 7 is up here. And if it's a pi over 6, all pi over 6s are 30-degree reference angles. So across from 30 is 1/2. This is radical 3 over 2. And again, since you're in the second quadrant, x is negative. 4 pi over 3. 4 pi over 3. If you see something over 3, you should be thinking 60-degree reference angle. So 60 degrees. We got 1, 2, 3. That's 3 pi over 3s. This is 4 pi over 3s. 60-degree reference angle makes this radical 3 over 2. The short leg is the x. They are both negative in the third quadrant. So negative 1/2, negative radical 3 over 2. 5 pi over 2. So pi over 2 means it's going to be one of those 90-degree reference angles. So let's count by 90s. We're going to go 1, 2, 3, 4. That's 5 pi over 2s. 5 pi over 2s is the same as 1 pi over 2. That's at 0, 1. So 0, 1. Another way of thinking about that is if you wanted to subtract out a full rotation, then you would have to subtract out 4 pi over 2s because that's 2 pi. So 5 minus 4 is 1 pi over 2. These are coterminal angles. 5 pi over 2 and pi over 2 are coterminal. They are the same terminal point at 0, 1. Okay, so now we'll do a couple evaluate problems, and then you guys can work on your checkpoints. So let's do 5 pi over 6. So first thing, you got to remember, pi over 6 is a 30-degree reference angle. I always think of this being 6 pi over 6, because that's 1 whole pi, and 1 less than that is 5 pi over 6. So if it's a 30-degree reference angle, the y is 1/2, the x is negative radical 3 over 2. And they want the sine, so remember, if this is my angle, opposite over on the unit circle, hypotenuse is 1, opposite over hypotenuse, the sine is the y, so the sine of 5 pi over 6 is 1/2. Cosine of negative pi over 3, so negative means we're going to go clockwise, and pi over 3 means 60-degree reference angle, so in the fourth quadrant, this would be radical 3 over 2, it's negative, this would be positive 1/2. And cosine, if you think about it as your reference angle here, adjacent over hypotenuse, adjacent is the x. So the cosine of negative pi over 3 is also positive 1/2. Okay. You got 30, 60, 90 triangles. There's not going to be very many different answers, guys. Okay, look. They both have 1/2. They both have radical 3 over 2. So tangent of 2 pi over 3. Tangent can mess with you, so let's first identify that in 2 pi over 3 is up here in the second quadrant. And if it's over 3, it's always a 60-degree reference angle. So that's radical 3 over 2. And this is 1/2. Now, if you remember that tangent of 60 is always radical 3, then realize that in the second quadrant, it's a 60-degree reference angle. So it's radical 3, but since x and y are opposites, it'll be negative radical 3. So you can just remember that. Or you can copy, change, flip. It's just annoying. So opposite over adjacent would be radical 3 over 2 times the reciprocal. It is still negative. Those will cancel out, and you get negative radical 3 over 1. So the easy way to do that is, since you're going to do it every day, is remember that the tangent of a 60-degree reference angle is radical 3. Couple more. Secant of 7 pi over 4. So pi over 4 is 45 degrees. 1, 2, 3, 4, 5, 6, 7 pi over 4. A full rotation would be 8 pi over 4, or 1 less than that. Since it's pi over 4, this is radical 2 over 2, and radical 2 over 2, it's a 45-degree reference angle. Y is negative. What do we want? Secant is the reciprocal of cosine. If cosine is the x, then I want the reciprocal, so 2 over radical 2. But you do have to rationalize that, so you get 2 radical 2 over 2, which just becomes radical 2. All right, last couple. Cotangent, 3 pi over 4. 1, 2, 3 pi over 4s is in the second quadrant, 45-degree reference angle, so radical 2 over 2, radical 2 over 2, x is negative. We want cotangent. Well, this one's actually really easy because tangent is opposite over adjacent. The tangent's negative 1. The cotangent would be adjacent over opposite, which is still negative 1. If it's an isosceles triangle, the legs are the same, so you divide them by themselves, you get 1. Last one, sine of 3 pi over 2. Remember, that's 90 degrees, so 1 pi over 2, 2 pi over 2, 3 pi over 2. 3 pi over 2 is down here. I always label it as 0, negative 1. And if you want the sine, you want the y, so the sine of 3 pi over 2 is negative 1. So that's it for radians. Make sure you do your evaluate in radians terminal points checkpoint, and then you have all your other ones you should be getting done. And while you're at it, hit that like and subscribe button.